So, first of all, we are going to discuss the nomenclature of the tetracycline before going to start the SAR. See here, the numbering of various carbon atoms and subsequent leveling of the four aromatic rings. These are the four aromatic rings present in the tetracycline nucleus. Now, we are going to give the nomenclature of the oxytetracycline. Means why? Because oxytetracycline, it is the first discovered tetracycline. So first discovered tetracycline is called oxytetracycline. This oxytetracycline is chemically we can designate it as, see here, in 4 position dimethyl amino group. In 4 position dimethyl amino group. So we can give the nomenclature 4 dimethyl amino, 4 dimethyl amino, 1 4 4a, 5 5a, 6 11, 12a, octahydro, 3, 5, 6, 10, 12, 12a, hexahydroxy, 6 methyl, 1, 11, dioxo, 2 naphthalene carboxamide. So see, you see the structure. Depending upon the structure and numbering of the compound, we can give the nomenclature. So 4 dimethyl amino, here 4 position dimethyl amino group, and octahydro, octa means 8. So in octa means in 8 carbon there is a hydrogen atom. Generally we can consider the hydrogen atom, and sometimes they are considered OH. So that's why octahydro means 8 hydrogen atom. That's why it is octahydro. In which position this is? 1, 4, 4a, 5, 5a, 6, 11, 12a, octahydro. And 3, 5, 6, 10, 12, 12 hexahydroxy. Hexahydroxy means hydroxyl groups, 6 hydroxyl groups. 6 hydroxyl groups in 6 position. And 6 methyl. Again in this 6 position, again in this 6 position, methyl group is there. In case of chlorotetracycline, 6 methyl, 1 and 11. In 1 and 11 position, oxo group, 2 keto group is there. See, 11 and this 1 and 11. So 1 and 11 dioxo, 2 naphthalene carboxamide. So this is the nomenclature of the oxytetracycline. So we can give the nomenclature on the basis of the oxytetracycline to the other also. See, this is the structure, and again here you are written. You see, we can give the nomenclature in two ways. This is the first way. You can write the second way. This is also correct nomenclature. See, 4 dimethyl amino, 3, 5, 6, 10, 12. 12 hexahydroxy, 6 methyl, 1, 1, 11, dioxo, 1, 4, 4a, 5, 5a, 6, 11, 12a, octahydro, tetracene, 2 carboxamide. This is also correct nomenclature. You can give the nomenclature in two ways. These both are correct. Now you see here, we are giving the structure here. See, this is the structure of oxytetracycline. Oxytetracycline. You see the, now you can clearly understand that. See, in this is the numbering giving 1, 2, 3, 4. This is 4a. This is 5, 5a. This is 6, 6a. Then 7, 8, 9, 10. Then 10a, 11, 11a, 12, 12a. Now we give a nomenclature. You give, see, in the fourth position, dimethyl amino group is there. So this is, we can write 4 dimethyl amino. 4 dimethyl amino. Now hydrogen you consider, that is 3. Here octahydro means what? Octahydro means either hydroxyl group or either octahydro. You see here 3. In 3 position, hydroxyl group is there. 5 position, hydroxyl group is there. 6 position, hydroxyl group is there. 10 position, hydroxyl group is there. 12 position, hydroxyl group is there. 12A hydroxyl group is there. So means that's why it is called octahydro. In in 8 position there will be hydroxyl groups. That's why it is called 3, 5, 10, 3, 5, 6, 10, 12, 12A. 12A hexahydroxy. Hexa means 4. In the 6th position, 6 hydroxyl group is there. 1, 2, 3, 4, 5, 6. In this 6th position, 6 hydroxyl group are present. That's why it is called as hexahydroxy. Hexahydroxy. Now again in 6th position, methyl group is there. Again in 6th position, methyl group is there. That's why it is called 6 methyl. 6 methyl. Now in 1 and 11 position, ketone group is there. So that it is called 1,11 dioxo. 1,11 dioxo. Next, in this position, there will be octahydro. In this position, either it is present in the what? See here, octahydro means 1. Basically, what hydro means hydrogen, na? Hydro means hydrogen. Means if you consider this, if you do not put this ketone group, so we can assume that here hydrogen will be there. Remember, all this ketone group or other group, these all are replacing the hydrogen. That's why that hydrogen name will be intact. That hydrogen name will be intact. Whatever in this position it is there, but we can designate as a hydro. So 1, 4, 4A, 5, 5A, 6, 11, 12A, octa hydro tetracene 2 carboxamide. In two position, amide functional group is there. In 2 position, amide functional group are present. That's why it is called 2 carboxamide. And this is octahydrotetracene. Octahydrotetracene. In these all 8 position, hydrogen will be removed and other functional group is placed. So that's why although hydrogen is removed, but the name of the hydro will be intact. That's why it is called octahydro. So this is the nomenclature of the oxytetracycline. Next, here you see, here we are giving this all the substituent. See here, R1, R2, R3, R4, R5. So introduction of the different functional group in different position lead to the development of different types of tetracyclines. Now we are showing this one. See here, this is name of the antibiotics: R1, R2, R3, R4, R5. So depending upon the introduction of the functional group, various tetracyclines are developed. So now we are going to discuss the SAR of this tetracycline depending upon the structure. So in case of SAR, you remember first point, the keto-anol tautomerism. Here, the keto-anol tautomerism between C2 and C3. C2 and C3, keto-anol tautomerism. Keto-anol tautomerism at C2 and C3. C2 and C3. Here it is ketone group. It is here OH group. So this position, the keto-anol tautomerism between C2 and C3 is very important for tetracycline. To show the biological activity. Means you see, keto-anol tautomerism means This hydrogen become coming to here to form a OH group, and this bond going to here to form a double bond. So it may be formed in three position become ketone group, and these two here become a hydroxyl group. So that is called keto-anol tautomerism. So the keto-anol tautomerism between the C2 and C3 system of tetracycline is essential for biological activity. Essential for biological activity. Now, any modification in this system can be resulted in loss of activity. Now, if this ketoanol tautomerism you remove or replaced, it will lose the biological activity of tetracycline. So the first point you remember, the ketoanol tautomerism at C2 and C3 position is essential for the biological activity of the tetracycline. Any modification between this system, it will lead to lose of biological activity of the tetracycline. This is the first point. Second point, the amide functional group. This is the amide functional group at C2 is essential for antibacterial activity. The amides, this is a carboxamide, C, CuNH2. If the R2, if R5 is H, that become NH2. So this is called carboxamide amide functional group. So the amide functional group present in the C2 position is essential for the antibacterial activity of the tetracycline. Substitution Substitution at these amido group, substitution of these amido group can result in hydrophilic compound which can be taken orally. Now, if you substitute this amide group with other functional groups, then the compound becomes hydrophilic, which is taken by oral route, which is taken by oral route. This is the second point. Second point means the amide functional group is essential for the antibacterial activity of the tetracycline. Any modification of these amide functional groups lead to the hydrophilic compound which are taking orally. Second point. Third point. Third point come here. Due to the presence of dimethyl amino group, see, due to the presence of dimethyl amino group in the fourth position, due to the presence of the dimethyl amino, due to the presence of dimethyl amino group at fourth position, what will happen? Tetracycline exists as a zwitter ion. Remember this, due to the presence of dimethyl amino group, tetracycline exists in zwitter ion, which enables it to distribute in the body. Means due to this presence of the dimethyl amino functional group, it forms a zwitter ion, na? Zwitter ion. Due to the formation of the zwitter ion, it can be easily distributed in the body. Loss of activity observed when the dimethyl amino group is removed. Remember, due to the presence of the dimethyl amino functional group at 4 position, tetracycline form a zwitter ion. Due to the formation of the zwitter ion, tetracycline are easily distributed throughout the body, and removal of this dimethyl amino functional group lose its antibacterial activity. Lose its antibacterial activity. समझ में आ रहा है? Again, I am explaining. First point means the presence of the ketoanol system. Ketoanol system between the C2 and C3 is essential for the antibacterial activity. Antibacterial activity. Any modification of this system result the loss of activity. Second point, the presence of the amide functional group is essential for the antibacterial activity of the tetracycline. Any modification of this functional group form a hydrophilic compound which can be taken easily by oral route. Third point, the presence of the dimethylamine functional group, it forms a zwitter ion. Due to the formation of the zwitter ion, the tetracycline can be distributed throughout the body very easily. and removal of these dimethylamine functional groups lead to the